Hello, it's Valentine from Simplistic. So in this problem, we're going to basically what's given to us is the decomposition of ozone to oxygen and O. And the data for this decomposition is given to us. So we have the temperature decreasing from 600, increasing from 600 right up to 1900 in increments of 100 Kelvin. And the rate constant is given to us for this reaction. As you can see, the rate constant is changing for as the temperature increases. So what we are looking at is an Arrhenius equation for this problem, because the Arrhenius equation basically draws a relationship between the rate constant and the temperature. So the form of the Arrhenius equation we're going to use, I'm going to just write it out here. I'm going to put a little text box out here. Okay, so the form of the Arrhenius equation, let me increase the font size. Okay, the form of the Arrhenius equation we'll use is ln of k, so the log of the rate constant, so ln of k is equal to, put a little colon out here, is equal to negative activation energy EA divided by R times T. Okay, so R is the ideal gas constant and T is the temperature in Kelvin, and this entire thing is added to ln of A, where A is the activation factor. Okay, all right, so we have this equation, this Arrhenius equation, and as you can see the way we've written it out, this is essentially the equation of a straight line. So if you compare this to the straight line, y is equal to mx plus b, where y is equal to ln of k. M is the slope of the line, and that is actually equal to negative EA by R divided by R. And T, I'm unable to select that. Okay, so T, the temperature, is actually X. And then B, which is the y-intercept, is ln of A. All right. So in order to answer this question, the first thing we need to do is we need to create a plot of ln of K versus temperature. So let's go ahead and do that. Okay. So K, which is the rate constant, okay, is going to be your y-axis values. Okay. And give me a second. Right. Okay. So ln of k, not k, ln of k, which is your rate constant, okay, is going to be on your y-axis, and then 1 over t. Okay, so see, you have negative EA over R. This, and let me put this in parentheses, that way we're very clear, is equal to 1 over t. So 1 over t is your x-axis. Okay, so let's go ahead and first write out what we have out here, and I'm going to type all this out and then fast forward the video to kind of get rid of the time you have to watch me typing. So here we go. All right, so I've typed up the temperature and the rate constant out here. As you can notice, the difference is the rate constant is given in scientific notation in the problem, and I have changed it from scientific to standard notation. Okay, now the next thing I want to do is I want to calculate ln of k. Okay, so I have to take the log of these values out here. So I'm going to write log k, so equals ln, that's the formula, open parentheses, I just select that cell, close parentheses, and enter. So that is, and then I'm just going to take my mouse out here and see how the arrow changes from a hand to a see how it changed from a hand to a plus sign, and then just double click and it'll fill in all the values. Okay, the next thing I want to do is I want to create 1 over t. Okay, so for 1 over t, I'm going to just insert a cell out here, a column out here, and write 1 over t and I'm just going to take the reciprocal of this value. So 1 equals 1 divided by 600, and that's 1 over t. And then I'm just going to go ahead and do the same thing I did for ln k. I'm going to just double click out here, and there I have my values. So now I'm going to create a plot of these two with these two columns. So I'm going to go to insert, I'm going to click scatter, and there you go. So I have a nice straight line out here where, and you don't have to put titles and all on this plot, but look at that straight line. So essentially what we need to understand is that ln of k should be the y-axis. Okay, so let me not let this confuse you. Ln of k is the y-axis, and then this is the x-axis, okay, which is 1 over t. And in fact, just to kind of make this a little easier for us all to understand as I'm speaking, I'm just going to go ahead and label the axes. So I'm going to go to add chart element. I'm going to go to axis titles. Actually, yeah, I'm going to primary horizontal, and I'm going to call that 1 over t and delete the rest. Okay, and then I'm going to go back to chart element. I'm going to go to primary vertical, and then out here I'm going to do ln of k. All right, so there you have it. Next thing I'm going to do is I'm going to find the best fit straight line. So I'm just going to select one of the data points. Sometimes it selects all of them. Go to chart element. I'm going to go to trend line. I'm going to go to linear, and there you have it, the best fit straight line. The next thing, I'm going to go back to chart element. I'm going to go to trend line. I'm going to go to more trend line options, and I'm going to find the equation, display equation on chart. And there you have it. That is my equation. All right. So I'm going to write that equation out big out here so we can look at it, so it's easier to look at. Okay, so that equation is y is equal to negative 11201 x plus 26.79. All right, I'm going to increase that font size. All right, so that is my equation, okay? And so what we need to understand from this equation is that negative, let's see, so is that EA divided by R is actually equal to this value out here, just this value, okay? And then ln A is equal to this value, because if you compare it with this straight line on the equation of a straight line, that's what it comes out to be. So now we're in a position to answer the questions out here. The first question, determine the value of the frequency factor. Okay, so the frequency factor is A. So to find the value of A, we simply have to take the anti-log of 26.79. So let's do that out here, and we can actually do that in my calculator. So we'll do A is equal to E raised to 26.79, and that ends up being 4.36 times 10 raised to 11. Okay, so that's the value of the frequency factor. The next thing we want to find out is the rate constant, right? Sorry, the activation energy for the reaction. So the activation energy, notice carefully, we have EA out here over R is equal to 1120. So the activation energy, and I'm going to put that into a formula out here in Excel itself, so we can kind of let Excel do the calculation for us. So we're going to do EA over R, so is equal to 11201. So I'm going to write 112. Let me just rearrange this first. So EA is equal to 11201 times R. So now R we're going to get from a different from the R will usually be given to you in a problem. So we're just going to type that in. EA is equal to 11201 times R actually is 8.31. Okay, and that ends up being 93,080.31, and with the correct number of significant figures, that should be 93100, and that's joules per mole. But you can also report it in kilojoules per mole, so that should be 93.1 kilojoules per mole. That is your activation energy. Then the next question is, use the results of the Arrhenius analysis to predict the rate constant at 298 Kelvin. All right, so for that we have to use the equation of the straight line given to us. So we're going to predict the rate constant. So all we have to do is we're going to express this. Let's see. We're going to write out the equation first. So the equation is ln of k. So ln of k, we're going to solve for that, right? So ln of k is equal to negative EA by R. Now EA by R we already know is this value out here, which comes from the equation of the straight line. So that's minus 11201, and then the temperature is actually 1 over x. So really that's times 1 over 298 Kelvin. That's the temperature we're given. Okay, and plus ln of A, which is also given to us, which is 26.79. 26.79. And then we just hit enter. There's a typo in my formula. Oh, I forgot to add the multiplication sign. All right, we'll accept that correction. So that's negative 10.79727, and then k would be e to the power that. Okay, so I'll just do that in my calculator. So the way I would do this is I just type 10.79725, hit the plus minus sign, and then I'd hit e to the power x, which is going to give me 0.000020045. We'll stop there. It goes on, but we're just going to stop there. Okay, so that is the value of k, and actually for the correct number of significant figures out here, let's see, we're going to keep it with 3 significant figures. Okay, so 205. All right, so this is the value of k. The unit actually ends up being, let's see, well, we don't know what the rate constant, oh well, the unit is per molar per second. All right, and there you have it. You can convert this to scientific notation if you want, or you could just keep it as is. I hope that made sense. Thank you for watching.